All right, team, we'll try this again because this didn't work. Round 2 works. All right, so flip video 5.2. 5.2, we are discussing how agriculture has evolved over time. We're looking specifically at the second agricultural revolution, whose practices began and the social changes began as early as the 1750s, but I'd like you to focus your attention primarily upon what happened from 1850s on. In the second agricultural revolution, farmers achieved higher yields per acre. Yields is their output. With technology, fertilizers, the industrialization of agriculture, and something as simple as just improving the collars that were used for the draft animals, the working animals. This all began in England, and this primarily began in England because of the river system there, as those of you who have studied the Industrial Revolution know, that provided both transportation and the ability to transport resources. On the whole, I want you to consider the second agricultural revolution as the way that the mechanization of farming was introduced. What this will ultimately lead to is what you see listed here is industrial farming. So you can see at the bottom the end product over the long term for this is industrial farming. So as I just mentioned, this revolution generally coincided with the Industrial Revolution. So let's talk about the social changes of the Industrial Revolution so we can see how that affects the agricultural practices. This first began here with something that's known as the Enclosure Movement. And the Enclosure Movement was a series of acts, and you can see on the bottom left as early as 1700s, where wealthy landowners were given the opportunities to buy out land from poor farmers. And you can see on the bottom left, or bottom right, excuse me, you can see the English settlements and land patterns before the Enclosure Movement versus after. And you can see that those farms have been consolidated. And the whole point of the Enclosure Movement was that England's population was growing, and they believed that there was a more effective and efficient way to divide up the land and to make it more agriculturally productive to feed these growing populations. So the consequences of this movement were that these now landless landless farmers who are now in need of a job started beginning to move to cities. So we have an increasingly urbanizing population. All of this should sound familiar from the demographic transition model. We've got urban industrialization, increasing urbanization. So, but the problem, or not so much problem, but the cycle here means that those people living in the cities, that puts greater pressure on this land right here because now people who are not living on those that are not producing food and living in cities now need these larger farms to be more agriculturally productive, to create more food to feed them. So in turn, we have not only these larger farms, but we have a greater demand of what needs to come out of that farm. So you can see the consolidation of land with the Enclosure Acts. Those poor farmers moved to cities. Larger farms now need those higher yields to feed this increasingly urban population. We also have transportation changes, of the Industrial Revolution. The cause of these transportation changes is that we've got new forms of energy, specifically coal. Coal is what's fueling the Industrial Revolution. That's fueling the factories and ultimately going to fuel ultimately fueling these factories in general and the ability to transport the railroads and things over time. It leads to better transportation, such as railroads. I'm sorry. So we've got new steam engines, we've got railroads, we've got steamboats. And the effect of this is that we now have the ability to sell food to far greater distances, meaning that there are now new markets where food can be sold, since it's now ultimately moving. And eventually, what you see in the bottom right, in the latter part of the second agricultural revolution, that food can now be refrigerated. So all of a sudden, if you can now sell food to massive markets and ultimately global markets, well, people are going to want to make agriculture even more productive to help meet that demand and take advantage of those markets. We've got technological changes of the Industrial Revolution, a laundry list here. They're starting to use horses in the agricultural production process. We're using, as I already mentioned, improved collars on beasts of burden. Those are animals that are used for carrying workloads. We've got better forms of field drainage to ensure that the crops are not being drowned and or are not getting too little water. Better forms of irrigation. So now, again, speaking of the watering system, making sure that the water is reaching the crops itself. That's what irrigation is. Better forms of food storage. Just mentioned that as well. And now this one here is an important one. There's better just generally understanding how soil nutrients work. And what we see now is a new form of crop rotation emerging. Crop rotation is when historically you have that three field crop rotation produce one crop on that's area number 1, different crop on area number 2, and you leave an area what's known as fallow, or you leave it alone so that the nutrients in the soil is able to be rebuilt. Well, the old way is just continue to rotate those through. So what was left fallow will now rotate here. This crop will now go back to what was once left fallow, so on and so forth. That was the old way, 3-field crop rotation. Well, as the Industrial Revolution and the Second Agricultural Revolution occur, there's a new more economically productive way, which is to simply use different crops that interact with the land differently. So you always will have an economically productive crop rotation if you've got 3 different crops who exert different energies and different pressures on the land. Well, then you can constantly have crops being grown and you can constantly use them for profit. Lastly, we got the introduction of new technology, such as threshers. Threshers are things that shake the crop away from the stalk, and actually you can use then therefore use that crop. And then the reapers are ones you think of the Grim Reaper with his tool. That's a reaper. You slash that down. What that ultimately usually looks like in modern day are what's known as combines, and those have accomplished many of those tasks. But you see the early introduction of these mechanization and these mechanical examples of farming. Agriculturally speaking, some of the specific changes that are also occurring sort of as a byproduct of this, since we have wealthier farmers, those farmers can now start to experiment with selective breeding, both with plants and animals. If they see that there's a crop that's this is just simple logic. A lot of people misunderstand this as genetic modification. Simple breeding has been used, crossbreeding of animals and plants has been used for a very long period of time. That's why we have dogs that look so wildly different. Anyway, the plants, if you have a very nice red big apple, then you're going to want to continue to produce that big red apple. So you're going to try to breed those plants in that way, and use the seeds. That's poor terminology. I'm sorry. We're trying to use the most beneficial and sought after characteristics of each one of the crops that you'd want to create. And you can do that with both plants and animals. You've learned likely about this in biology, so that should look familiar in the top right. Bottom left, you can see, for example, is a wild chicken. Well, that has been domesticated and its characteristics changed so much that the bottom right is the chicken that you and I are more familiar with. So we start to see some of this experimentation occurring in the end of this second agricultural revolution. We also have initial uses of pesticides and herbicides, pesticides and insecticides. Pesticides are getting rid of specifically pest crop there. Insecticides targeting animals and insects that you don't want. And these for the most part, we're talking about natural fertilizers here and pesticides in the early mid 1800s. It doesn't come until the third agricultural revolution that these become synthetic or chemical. We also start to see what's known as the specialization of farming. What we're now starting to see are the early signs that the creation of the food, the farming, is starting to differentiate from the actual production of the food in factories. What in the 1700s, if you talked about a dairy farm, you've got the cows being raised, the milk being processed and produced and distributed all on the same farm. By the 1900s, some of those processes are starting to occur in different places. The cow may be raised in one place and milked in one place, but it's going to be transported and then maybe bottled and produced in a factory and then distributed somewhere else. What we're going to see the conclusion of that is going to ultimately build into what I have in italics because it's going to come later on, not part of the second agricultural revolution, is known as agribusiness. And that's when we're going to see large scale businesses owning all steps of this production process, from the farm, they say, to seed to market. So the distribution and the production of all of that being owned by a single business known as an agribusiness. But we start to see those seeds for this that being planted. Haha, little pun there. Seeds of this being planted here in the second agricultural revolution. Which brings us to the third agricultural revolution, which is considered to have started in the 1940s and 50s and really continues up through present day. And what this is the third agricultural revolution refers to the practices of MDCs and the technology of MDCs being used and diffused to LDCs in order to help feed their growing populations. And this was also known as the Green Revolution. All different types of examples of this practices that are associated with this, but the key differences here, you'll notice already, artificial fertilizers. So we're starting to see chemical fertilizers being used as opposed to perhaps natural ones. We have large-scale irrigation, chemical pesticides, Genetically modified organisms are also known as GMOs when we're using specific characteristics of one plant and using and biotechnology to then implement those characteristics into a different part of the plant, or either a different plant entirely or a different plant component of the same plant, in order to get better characteristics or more desirable characteristics. Mechanical machinery is being improved, crossbreeding, as I just mentioned, and hybridization of different yields. This Green Revolution began with this man in the top up here named Norman Borlaug. And Norman Borlaug was responsible, I'm going to skip ahead for a second, for creating dwarf plant varieties of plants. Dwarf varieties are when you can see it's listed. I don't know if I have a picture of a dwarfed variety, do I? I guess I don't. The dwarfed varieties essentially are when you have a small variety of the same plant. And if the plant itself is shorter, then it's less likely to topple over and you're less likely to lose the crop with the plant itself. That's why it's called dwarf varieties. When Norman Borlaug came up with high yield rice and wheat varieties, specifically um, dwarf varieties, for use in Mexico and India. So he's got the wheat production in Mexico and India, rice production in India. It was largely based upon the use of these chemical fertilizers, and that because this meant that they required less water, and they were essentially just more productive crops. Well, that green revolution essentially saved India and Mexico, and then it absolutely um, the is without more specifically in India, they likely would have faced widespread famine had it not been for the work of Norman Borlaug. And Mexico, similarly, you can see from 1945 to 1975, their ability to produce wheat just simply skyrocketed. But do note, that doesn't mean that this was universally successful. For example, there were no successful varieties developed for sorghum, which was the common plant that is grown in many areas of Africa. So this wasn't a catch-all solution for everyone. But for specifically in Mexico and India, it got so successful in India that India was able to continue to feed its own population without necessarily having to rely upon imports for some period of time. And you could just simply see in general just the yields of these wheat varieties truly skyrocketing. So enormously increase the wheat production. That just simply means there's also more money for the farmers. They're able to sell the surplus crops. Increase caloric variety per person, meaning that the people are getting better nutrition, and they have a more diverse diet than was once available. In a highly populated country, the land is at a premium, and when you can grow things more efficiently and more effectively with higher yields, that means you don't have to use as much land. If you're not using as much land, well, that land can now be used for something else besides farming, and that too is an advantage. And lastly, these high yield varieties, many of these ultimately becoming drought resistant crops, that means that places that don't get high rainfall are still able to be farmed with these new practices of irrigation, and as I mentioned, the crop varieties themselves. So I mean, this is really a massive gain in that sense for these different regions of the world. But that doesn't mean it didn't come without criticisms. So many people argued that the third agricultural revolution meant the loss of biodiversity, so the variety of plant life in given places, and really favored what's known as monoculture, when you've got a single crop that you're growing over and over again in the same space, that in many ways does not offer that same biodiversity of an environment. This was also criticized as being very expensive to maintain, and it's true. You need lots of infrastructure, lots of different road systems, for example, machinery, different systems that a lot of LDCs just simply didn't have, and made them dependent upon MDCs for this technology, and just was often difficult to be maintained over a long period of time. A lot of people criticize the environmental damage, citing underwater ground contamination, for example, of pesticides or of the fertilizers. A lot of people argue that there's unintended consequences of introducing foreign varieties of plants into areas that they're not native to, and there are a lot of consequences for doing so. And some people cite desertification, which is essentially that instances where the fertile land ultimately becomes desert and it can't be used anymore. So and there's also just a lot of criticism in general about this idea that this is just simply making LDCs even more dependent upon MDCs. But then, of course, the counter argument is this here, which is that in a world of growing population, particularly in those same countries, there's are we going to let people starve, or are we going to seek a way to address this? So very, very controversial, and something that you're going to continue to look at on your own and in class today. So here is the question. There's this screen and this screen are the ones I'm referring to for question number 4. Thanks, guys.